This project focuses on the restoration of first-seasonal wetlands located between Hormood and Karmostaj villages, near the city of Lar, in Fars province, southern Iran. The study area is located within a hot and arid climate zone known for severe evaporation, limited rainfall, and increasing water scarcity. Despite these harsh conditions, the region has a long history of traditional water management, including ancient cisterns and seasonal reservoirs. This project aims to revive that legacy using modern science and sustainable technology. Currently, 4 small seasonal wetlands exist in this area. They fill during short rainfall events, but lose most of their stored water within weeks due to evaporation, infiltration, and salinity intrusion. As a result, these wetlands fail to support biodiversity, local livelihoods, or groundwater recharge in a meaningful way. Without intervention, climate change and rising temperatures will further reduce their ecological and economic value. Due to the lack of long-term hydrological stations in the immediate area. This study applies a simulation-based approach using climatic and hydrological data from similar regions such as Laureston, Bastic, and Lamerd. Average annual rainfall is estimated at 200 millimeters, while annual evaporation exceeds 3,000 millimeters. Based on conservative runoff coefficients, each wetland receives approximately 10,000 cubic meters of water per year, resulting in a combined annual storage potential of about 40,000 cubic meters. To increase water retention, the first strategy is geometric optimization, increasing wetland depth while reducing surface area. This alone can reduce evaporation losses by up to 40%. The second strategy is sealing the wetland beds and sidewalls using high-density polyethylene liners, or HDPE, which can reduce seepage losses by more than 95% and prevent salinity intrusion from surrounding soils. Low-cost alternatives such as compacted clay and bentonite are also considered for selected zones. A key innovation of this project is the combined use of floating polyethylene covers and floating solar photovoltaic panels. These systems significantly reduce evaporation while simultaneously producing renewable energy. Partial surface coverage between 30 and 40% can reduce evaporation by up to 70% in covered areas, while generating clean electricity for pumping, monitoring, and potential grid injection. Ecological restoration focuses on planting native and salt-tolerant species such as tamarisk, reeds, and salicornia to stabilize soil, reduce wind erosion, and improve microclimates. In parallel, economically valuable crops adapted to saline and arid conditions, such as aloe vera, quinoa, and cedar trees, can be cultivated around the wetlands using the stored water. This project is inspired by successful international experiences in India, Australia, Morocco, and Spain, where small artificial wetlands have been restored using liners, floating solar systems, and climate-adaptive vegetation. By integrating traditional knowledge with modern engineering, this approach transforms seasonal water loss into long-term resilience. The total estimated investment for restoring all four wetlands is approximately $680,000. Annual revenues from solar power and climate-resilient agriculture can reach $80,000 to $90,000, with a projected return on investment within 7 to 9 years. The project creates direct and indirect employment opportunities for more than 40 local residents. This project demonstrates that even small seasonal wetlands, when properly designed and managed, can become powerful tools for water security, ecological restoration, and sustainable rural development. It represents a modern evolution of ancient water wisdom, designed for the challenges of the 21st century.